Where did I put it? It's still one time allowed. Sorry. I thought I changed the setting last week. Right? Yes, that's the reason. We have to be clear about our thoughts about how we're going to deliver the confusion or the problem that we need someone else's to help with. So that is like decomposition, breaking tasks into. Try to refresh it. It should work now. Okay, that's great, Xinjiang. So for those who are having the chat problem, this is caused by the hiccup in the traffic of the network last Friday. So we already reset everything on the server. Yeah, it should work, but if it didn't, you have to clear out your cookies, your history. Then if it still not work, you have to tell me. So for Wednesday lab session, the 9 o'clock will be belonging to group A. So the group A and group E need to be switched because of the clashing. So group A will be from 9 to 11 for Wednesday. Group E and group B will be from 11 to 1. And group C and D will be on Thursday. Okay, Pirunta, is it working? Okay. Sorry, I didn't read the last message. And group B to 11 for Wednesday. So group E and group B from 9 to 11 the clashing. So group A will be from 9 to 11 for Wednesday. Okay, let me repeat about the lab session. So there is a bit of a switch of time for group A and group E. Group A, now your lab session would be on Wednesday, 9 to 11. Group E, your lab session will be on Wednesday from 11 to 1. Others are maintained the same. So A would be 9 to 11. The switch is made because of the clashing for those from group E with the tutorial, I think. Or with the language class, yeah. Okay, that's great, Pirunta. So don't be alarmed if you cannot finish all the 3 videos today, because although it's 15 minutes each, it is not supposedly, how to put it, the 15 minutes is the video recording. You will need more time to actually absorb the content that I'm trying to deliver to you. Is the change only for this week or the rest of semester? Provin, I assume you're asking about the asynchronous. So it cannot be for the throughout the semester, but this week we're going to give it a try. Okay,
composition, breaking
during class last week, I mentioned about the problem that we faced last week because the last week session is asynchronous. When it is asynchronous, you can have a direct contact with me in terms of you can ask me directly. Okay, for the university requirement, some component need to be synchronous. Every course, a certain percentage need to be synchronous, some percentage need to be asynchronous. So we cannot do asynchronous fully, but what I can say is for this particular week, we will do asynchronous. There is a concern, my concern was some people will have difficulty following this way of learning. So if I notice anyone left out, then I will go back to the synchronous approach. So can you explain what is the PowerPoint problem solving methods all about? So Norshasha, can you go to videos first? There are 3 videos explaining all the 2 slides. If you have a specific question, then put it in. So if you don't have any question, you are free to leave, yeah? This is not a class session. The class is inside the YouTube. Okay, the YouTube is purposely made unlisted so that I will focus only on my student, not to the public. Yeah? So there are some example here. In the overall picture. Second one is patterns. Pattern is about finding a similarity or differences in the overall picture. It will help us to make a prediction or lead us to shortcut. Pattern is always about finding characteristics or finding a match between a given set of information. Okay, let's look at some example here. So here, imagine that we want to draw a series of cats, but as we all know, cats has different features. Their colors is different, their tails are different, the fur is different. So, but we know definitely they have a series of fixed character like or fixed parameter. So pattern of the information that we are looking for. So abstraction is as although the name is a bit complex, it's basically mean generalization. What do I mean by generalization? So abstraction has the ability to filter out information that is not necessary to solve a certain type of problems. Remember when I gave you the code exercise, I gave that is not cat tails came from. Although the name is a bit complex, it's basically mean generalizing. That is not. What do I mean by generalization? So, abstraction has the ability to filter out information that is not necessary to solve a certain type of problems. Remember when I gave you the code exercise? I gave the final one. It doesn't matter. As I said, it doesn't matter whether you can do it or not. I just need to have a track of your progress. Um, there are three alphabet A, B, and C, where A and B is given from the program, and you can change the value later when it's needed. That is the concept of abstraction. The next one is algorithm. Algorithms. Algorithm is the ability to develop a step-by-step strategy for solving a problem. So algorithm is about what to do first, what to do next, and next, and next. So the sequence of instruction or sequence of process is important in algorithms. About how to deduce, try to make sense of what you write. That is the logical reasoning. It is like debugging, so it actually comes hand in hand with the logical for you to study, but we cannot.
雑音に惑わず、あるが自由だ。己の未熟を思い知る。なってにゃんにゃん。己の平穏に幼子やいやが一石を投じようと、バパウス殿は動じず、揺るがぬ様は山のごとし、平静を欠けば隙が生まれる。隙を突かれれば己の身は守れず、すなわち自由もそこになし。自由だ。己の未熟を思い知る。ねえねえ、タントちゃん、どうしたの？何？いや、新たな教訓を授かったところだ。そうなんだ。あ、そうだ、タントちゃん。ね、お姉ちゃんが仮装に
Do the game obviously, but
お姉ちゃんに。おお、いいな。未熟、装束。リベラ殿と。
Assalamualaikum and good day everyone. This is the continuation from second chapter, problem solving using computational thinking. Now, why we have a dedicated slot for problem solving method in program 4 is how can I Assalamualaikum and good solving. This will be the standard that you need to follow when you submit your assignment. Yeah? So probably inside it will be the standard. So problem solving methods consist of a few steps. The first is the problem analysis. The second is the designing of the solution or algorithm. The third is implementing the algorithm itself. Number 4 is testing and verification. And number 5 is documentation. So if you look at the steps properly, you can actually map this to the computational thinking technique that has been covered in the previous video. In the problem analysis, they actually involve decomposition, pattern matching, and abstraction. So here, in the analysis, you have to determine what is the input and output of the problem that you want to solve. And then you have to come up with a process or steps or produce the formula needed in order to solve the problem. You also need to identify the constraint. Sorry about that. So constraint is what is the limitation of the problem that you want to solve. Is the problem specifying anything that it can solve, but it also indirectly specifying the thing that it cannot solve? Or constraint can also be your program constraint. I cannot give you an example of program constraint just yet, but program constraint is the constraint provided with the how you actually write the program. Okay? So that is inside problem analysis. When we do problem analysis, there are some questions that we need to answer in order to really say that we already analyzed the problem. The first one, the important one, is we have to understand the problem. So what actually is the problem? You have to understand the problem to the point that you are able to write it down properly. And the next question is, what is the input and what is the output? So again, all these questions are specifically for analysis, the one that we just mentioned in the previous slide. Point, what is the process required? And the next actually constraint is the constraint provided already analyze the problem. The first one, the important one, is we have to understand the problem. So what actually is the problem? You have to understand the problem to the point that you are able to write it down properly. And the next question is, what is the input and what is the output? So again, all these questions are specifically for analysis, the one that we just mentioned in the previous slide. Point, what is the process required? Can you derive the formula? Is there any constraint to your possible solution? Is there any limitation of your solution? So these two is two different things. The first one, the constraint, is provided by the question itself. The limitation of your solution is caused by the program that you have written, that you plan to write. Let's now look at the designing of the solution. Designing a solution is more crucial than the program itself. In order to write a program, a code, well, we need to have a proper plan, and that plan is represented in design. Based on the analysis that we have found from the previous steps, we need to represent it either via pseudocode or via flowchart. So what is pseudocode? Pseudo itself means not. So pseudocode basically means not a code, while flowchart is a graphical representation using a very limited symbol, which each of them actually representing a meaning. We will have an example to show between the two, how pseudocode looks like and how flowcharts looks like. Next, we first go into the next step, implementation of the algorithm. Implementation of the algorithm requires translation from the design state, so you are transferring whatever you have written in pseudocode into a program. Bear in mind that pseudocode is a cross between human language and a programming language. Although the computer can't understand pseudocode, programmers often find it helpful to write an algorithm in a language that almost looks like a programming language, but still very similar to human natural language. As for flowchart, it is a diagram that shows the logical flow of the program. That's why both of these representation is easy to be met from the text version or from the diagram version into its corresponding or the correct program or code. So in general, there is only the following category from the pseudocode and flowchart. Sorry, I missed that one. So there is a sequential structure, selection statement, and repetition or iteration statement. We will look further into these three later, but to make the explanation more easy to absorb, let's start with example. So, assuming we have this question, easy to absorb. Let's start with example. This sequence region is defined. We will have an example to show between the two, how pseudocode looks like and how flowcharts looks like. Next, we first go into the next step, implementation of the algorithm. Implementation of the algorithm requires translation from the design state, so you are transferring whatever you have written in pseudocode into a program. Bear in mind that pseudocode is a cross between human language and a programming language. Although the computer can't understand pseudocode, programmers often find it helpful to write an algorithm in a language that almost looks like a programming language, but still very similar to human natural language. As for flowchart, it is a diagram that shows the logical flow of the